Hello everyone, thank you very much for watching this video where we discuss the second released version of the new experimental authorization server, and together with it we'll also discuss the PKCE authorization for the authorization code flow in an OAuth2 system, which is a subject that I know many of you are interested in. I avoided discussing this subject up to now because it was quite difficult to implement PKCE with the existing authorization server from the Spring Security OAuth project. It wasn't straightforward. You could do that, but you had to do some customizations yourself. And of course, many of you used PKCE authorization code only with Okta, Auth0, Keycloak and some third-party authorization server. So I actually wanted to create this video when we have a straightforward, out-of-the-box way to create the authorization directly with Spring Security, and that's what we have now. Of course, our authorization server is still experimental, so now we still discuss about an experimental version, which is version 002 that has been released about a week ago. And you know that I have created a video also for version 001, so you can check that one too in case you are interested in this feature. And we are still looking forward for some general available mature implementation of the authorization server, which will probably not be that soon, but at some point we'll have this, and step by step probably the fantastic team working on the authorization server will add new features up to the point where we'll have a stable version that will completely replace the need of using the Spring Security OAuth project, because that's the final purpose. So of course, don't forget to follow me on LinkedIn or Twitter if you want to see the next videos, and if you want to be the first one to be notified when I upload something on YouTube. You can also subscribe here. Now let's get started, and as you already know, I will write some code. I will use the second version that we have available. I have already opened the maven repository here, so you see this is version 002, still experimental, but the second version that we had, the first one was this summer, and now just this month we got the second version. And this second version, again, the main and most attractive feature of it is using PKCE with the authorization code. So let's try to use PKCE with the authorization code with this experimental authorization server by making use of this dependency. So yeah, I have to create a new project. So let me create a new project. New project, Spring Initializer. This is it. And then I'm using version 15, but that's irrelevant. I'm just using the last version of Java every time I can for an example, so that's why I'm doing that. How can we call this? Is the authorization server experimental demo, and this is the second demo because the first one was with version 001. So I will upload this on my GitHub account and leave you the link in the description and the comments of this video, so you can test it yourself afterwards if you'd like. And we can go next. The only thing we need to add is we need to add the Spring Web and the Spring Security. We will add manually the experimental authorization server dependency, because of course we won't probably find it here now. It will be sometimes until it will be completely fully integrated with Spring Boot as well. So that's why we'll probably have to use the web security annotation as well, and we will have to manually import some configuration in our project, but we will do that and it will work. And at some point when we have a mature implementation, you won't have to do that anymore, but now to do our proof of concept, we will have to add a few more rows in our configuration. But for here, so web, it's a web app, and then Spring Security, and we don't need to add the OAuth to any dependency from Cloud OAuth or something like that, because we won't use the old-fashioned Spring Security OAuth project, we want to try to use the experimental authorization server for that. So I'm actually creating this project. I don't think I need the old window, so I will replace it with our new project, and I have only one window opened here. That's to focus directly on our purpose. And in the POM.xml file, of course, I need to add the experimental server dependency. So I take it from here. I've seen that for some reason the team implementing the authorization server uses Gradle, but for simplicity I will continue to use Maven, so it's not a big deal. It's just the way you grab the dependencies, and from the point of view of the Java code, it should be the same thing. So I don't really think you will have any problem if you try it with Gradle yourself, because maybe you like Gradle more than Maven. So that shouldn't be a problem. And now, of course, the thing we want to write here is the configuration. Let's create a package first for our configuration. So I say this is the config, and here we have the project config. We annotate the project config with configuration, but I will enable web security as well, which if I remember correctly contains the configuration. So I could have skipped the configuration annotation, but that's irrelevant. I will just leave it here just for you to see that this is a configuration class easier. And the enable web security annotation that I add will probably be not necessary in the future with Spring Boot, when the authorization server will stop being an experimental feature, and we will have a let's say real feature. So then we also need to import the configuration here, because again, being experimental Spring Boot, at least this version of Spring Boot that's a general available version, doesn't know about the configuration of the authorization server, so you have to manually import it. So these two lines that I'm writing here, again, they will be not needed anymore at some point when this will cease being an experimental feature and will be a general available feature. But for the moment we really have to import this ourselves. If I remember correctly from the documentation and from the code that I have researched, this is OAuth authorization server configuration class that we have to import, and this should contain everything that's the pre-configuration of the authorization server, and that will again come out of the box with Spring Boot at some point when you need it. So with that being said, now we need to configure at least 3 things with this new authorization server, and these are the same things I have explained in the previous video about the version 001, so I will skip over them. I won't stay a long time detailing each of these, because we have already discussed them, and if you didn't see the first video, you can anytime go to it and find it on the same channel and watch it to get all the details you need. But as for any authorization server, you need to have user management, you need to have client management, and you need in this case you need to have a key management as well. So we need to add 3 beans in this configuration class, 3 beans that will be used by this authorization server. So for the users, it's still a user detail service. That's nothing new. The user detail service has always been the contract used by Spring Security to get the user details from a specific source, and of course you can implement this source whatever you'd like. It's only the contract you need to take into consideration that has this load by username method. You here deliver the username as the parameter value, and then the purpose of your implementation is to return the user details for that specific username. If you need more details into what this means, I have a full playlist of Spring Security out there that details it step by step. So when I describe this now, I assume that you already have some knowledge of Spring Security. Anyway, to discuss about OAuth implementations with Spring Security, you already need to know at least the authentication and authorization architecture. So I assume you know those, but if you don't know them, I have a full playlist, more than 30 hours of Spring Security step by step described on this same channel. So if you don't understand this, or if you are just beginning with Spring Security, before watching this video, make sure that you learn the very fundamentals of Spring Security, which you can do by free, just watching the playlist I'm sharing on this channel. So I'm adding this as a bin in the context, and because we want to focus only on the authorization server configurations, I'm going to create here an in-memory, I'm going to use here an in-memory implementation. So I just say user details service, and I use the in-memory user details manager implementation, and I simply create only one user. That's enough for us to test what we want to test. So say this is Mary, and her password is password. Not really secure, of course, but yeah, in general you should actually you should actually make sure you hash this password. But as I'm actually using always this no-op password encoder for the examples, because I want to allow you focus on the important stuff. And then we need some authorities. Say the authority for my user is read, and then we can build it, and we can add it to the user details service, calling the create user method, and return at the end the user details service. So now having this as a bin in the Spring context, Spring Security will be able to use it. I will create a password encoder as well. So because I'm now not hashing the password anyhow, I will just return the no-op password encoder. But remember, the no-op password encoder, which is marked also as deprecated, the reason why it's marked as deprecated is because you shouldn't use it in a production-ready application. So it's not deprecated because it has been used at some point and now it's not used anymore. It's deprecated from the very beginning, just to let you know that this password encoder is something you can use only in examples. That's because it doesn't encode anyhow your password, it doesn't hash it, it uses it in plain text, and that's something you should never have in a real world implementation, because somebody could of course steal your passwords and you don't want to have such a vulnerability in your application. But for examples, using it is great because you don't need to focus also on how the password is encoded. Sometimes I see beginners trying to use directly a bcrypt password encoder, and then they for example somehow miss something in encrypting the password, and then the authorization is not working, or sorry, the authentication is not working. And because they used this bcrypt password encoder, maybe they don't know that they missed something in the encoding, they believe it's something else, and then they lose a lot of time, and then they stress a lot because they find it's very difficult then to find where the problem is, because you have from the beginning used too many, you've tried to learn too many features at once. So I'm just now trying to exclude everything else and allow you focus on the important stuff that we are discussing. So I have created the user management. As for any other Spring Security application, we need the user details service and we need a password encoder. And I need to create the client registration, and it's called the client registration repository in this it's called a registered client repository in this case, which is different from the client repository we've used with the Spring Security OAuth, at least in terms of names, because the responsibility of the object should be the same. So it's registered client repositories. This is the name of the object we use in the experimental authorization server. It changed a little bit from what we knew when we used the Spring Security OAuth project, but the responsibility of this object is the same, and that is managing the clients known by the authorization server. So you need the authorization server know who the clients are, who the clients that can issue tokens are, and this is the main responsibility of this object that you of course need to as well add it to the Spring context. So of course in terms of OAuth 2, as you know, you should know, I assume you already know for this video, we have the main actors, which are the user, the client, the authorization server, and the resource server. So we are now implementing an authorization server, and the authorization server's purpose is to issue tokens that will be used by the clients to get authorized against the resource server. I will show you a diagram just a little bit after creating ourselves the configuration, and you will see there again, you will remember the link between these four actors when we discuss the authorization code flow, and then we will test the authorization code flow, and I will also discuss about the difference between the authorization code and using authorization code with PKCE, because that's one of the main discussions that we have in this video, and proving this way also that the version 002 of the experimental authorization server can use the authorization code grant type with PKCE, which is again something new, at least out of the box, wasn't possible with the previous authorization server from the Spring Security OAuth project. So we create a registered client, say call it client C1, and registered client with ID client. This is the ID used to register the client in the authorization server, not the client ID. The client ID is separate. We just say it's client 1, so this is the client ID. And then usually I would have specified a client secret, but in this case, because I'm using the authorization code grant type with PKCE, we don't need a client secret anymore, and I will explain it why immediately after finishing the configuration. And I will explain it on a diagram first, on a visual, so it's a little bit easier for you to understand how the authorization code without PKCE still works, because you can still use it. But now in this video, the differences that come with using the PKCE approach. So because we use the PKCE approach, we don't need a client secret, and again you will immediately see why. So what else do we need? We need a redirect URI. This is the URI where the that the authorization server will call. Actually, will redirect to when the authentication completes, after the user managed to authenticate. So I say, in this case, this is an URL we don't have, but we don't care. Say it's authorized or something like that. Again, we don't have this URI, we don't implement it. It will be a 404 when we'll be redirected to it, but the only thing that we need is the authorization code that we get, and you will see that when being redirected to this URI, you will as well get the authorization code. So that's why we need this URI here, even though we in this example we don't implement it. In a real world scenario, you of course need to implement it, because that's the continuation of your flow. Instead of creating a full app, we will skip that and we will use Postman to get the access token. So we have the scope as well. We need a scope for the client, and then what else do we need? We need the grant types, of course. So we need the authorization code grant type, and I'm only using here the authorization code. Again, with PKCE we'll be using it. And let me see, I still think I'm missing something. The client authentication methods, of course. And the client authentication methods, in my case, I will use basic authentication. All these parameters are new, so that's why I'm struggling to remember them, because they were not there in the Spring Security OAuth project, so it's a little bit different, but it's not a big problem. And then we have to use an in-memory implementation of the registered client repository as well. Of course, in a real-world scenario, you'd probably implement this interface and take the details from somewhere, a database, I don't know, somewhere else. But at the moment, we don't have provided by this project any other implementation than an in-memory one, and we don't want to lose time to create ourselves an implementation. We will directly use this in-memory implementation. which is more than enough again for our purpose. And again, hopefully I didn't miss anything here. From what I see, it's everything that I would like to see. And the last thing that I have to add to the context is the key manager. So key manager, and is this one from the Spring project. We call it key manager, and we make it also be in the Spring context by adding the @bin notation. And again, we are provided with a so-called static key generating key manager, which again we can use for our example. So we just use this one, which should be enough for what we want to prove here. And with this configuration, so theoretically with this configuration, we already have everything we need to start our authorization server and have the needed things, URIs exposed and everything, and details for user and client authentication and everything to try the authorization code. So when I'm running this, I should be able first in the console to see that I have all the URIs exposed by my authorization server, and then I will try to complete the flow for the authorization code and try to get in the end an access token. So that's the full purpose of what we are trying to do here in this video. So I'm looking here and I see that indeed our app is now started on port 8080, which is the default. And then we can see, of course, that we have the Auth to authorize endpoint exposed. We have the token endpoint exposed, where we should be able to call the authorization server to get an access token, and we have the keys token exposed as well. We won't discuss in this video about the keys token, but if you go into my previous video about the experimental authorization server, you will see I have proved how to call that one there as well. And it's just the standard keys token that comes with the OAuth 2 that shows you the public keys for the pairs you have registered in your authorization server. Now we are most interested on using the authorized endpoint. I'm going to this diagram, to this nice diagram I've drawn myself, and you can find it in Spring Security in Action as well, the book I wrote. Where I try to simply describe the communication between the actors when using the authorization code grant type. So I will try to remind you first how the authorization code grant type works, and then I will tell you which are the differences that that you will see when using the PKCE authorization code approach, which is a little bit more secure than using the standard approach. So assume the user wants to access through the client a use case in the application. So you have the client, which can be for example a web app in a browser, but it can also be a mobile application, and you use that, you are the user, you use that application and you want to do something with it, like you want to access your accounts, whatever that is. We don't necessarily care what that means in terms of the business use case, but we just want to do something with the application. So in order to do something with the application, you need to prove who you are. The client needs to call something from the resource server, because these accounts are the user's resources, and the user's resources in an OAuth 2 system are protected by the resource server. But to get the resources of the user, a client needs to first authenticate against the resource server, and to do that it needs to obtain an access token, which is this arrow here at the end, almost the end of the flow. So just before going to ask the resource server about the user's resources and getting them, assuming that the token is a valid one, the client needs to get this access token from the authorization server. And there are multiple ways in which the client can get the access token, and these multiple ways are called grant types. and we discussed about the authorization code grant type now, but in an OAuth2 system you can use the password grant type as well, you can use the client credentials grant type. We have an implicit grant type that's deprecated and you shouldn't use it anymore. Just if you don't know all this, just take my Spring Security playlist and learn them because they are important, or take my Spring Security in Action book and read it. You will find all the details you need there. Now, so in the authorization code grant type, the user needs to use one of its resources through the client. The client cannot get the resource from the resource server until it gets an access token. So to do that, what the client does is redirecting the user to a page on the authorization server where the user can directly use their credentials to authenticate against the authorization server. So the client tells the user, go here on the authorization server login page and tell the authorization server that you allow me to access that resource. If the user correctly authenticates using their credentials, then they will get back an authorization code. That's the reason why this grant type is called authorization code. So they get an authorization code for that specific client back. The client can use then the authorization code to get an access token. Now the problem is that in a just default way of using the authorization code grant type, to get the access token here, this line you see here, this one here, the client uses the authorization code got from the authorization server. So here is a redirect done by the authorization server to that redirect URI. That's the reason why we added this redirect URI. This is where it used. So to this URI, the authorization server will make a redirect, also providing an authorization code. And then that code is taken by the client and is sent back to the token endpoint to get the access token. The problem is that in between, if you simply use here the client credentials, then assuming that someone stolen the client credentials, now they are basically able to just get an access token by using the code that it's been provided through the redirect. So what we'd like to have to be more secure is a way in which, instead of using the client credentials to get to prove that the user that this is precisely the client for which the user inserted their credentials, for which the user authenticated, that the user allowed to access their resources, we have to make sure somehow that we have a link between this arrow where the user authenticates and says, I allow this client to access my resources, and this arrow here where we where the client actually gets the access token. So what solution can we find to make sure that this user is secure and is sure that they introduce the credentials, and that authorization code that will be provided back really is used by that client for which it allowed the access to the resources, and not by some other client that somehow managed that somehow managed to get the token from the redirect and has somehow the client credentials, because they are used for each call, and they are sensitive details in transition which can be stolen. So how can we get a little bit more secure in this and avoid such a situation in which somebody else can obtain the access token, which is not necessarily very easy. Don't understand that using the authorization code without PKCE, it makes it easy to get the access token and use it. It's not easy, but it's still a chance to do that. So instead, every time when this authentication happens here, when the user actually tells the authorization server, I allow this client access my resources, it sends a code that we call a challenge, and it simply sends the challenge, which is a code that's generated random, and theoretically you cannot know what that code is previously. You cannot anticipate the value of this code, so every time it will be a different code and it's random. Then we have two options. Either the same value should be used by the client here to get a token. If it's the same value, we say that we use an unhashed, a plain code challenge, but that's less secure, and that means that the absolutely same value sent here by the user as a challenge should be known by the client that will use it again. It's still a little bit more secure than using the client credentials because, well, you use a different value every time. So if somebody steals that value, it can still use it only for that specific flow and not for the next one, because the next flow will have a different challenge here. So it's still more secure than using the client credentials. But we have even a better way to secure this. Instead of using a challenge here that's identical with the value that we use for the verification, when we use the challenge, we use the challenge actually as a hashed value of the code that needs to be used to verify. So then when the hashed value, which is called the challenge, and that's the hashed value of the code verify value of the verification, when you use the hash value of the verifier, then somebody's stealing the challenge because it's hashed. It cannot get the value out of which the hash has been created, because that's the rule of hash. You can get back the value. So then nobody besides the client itself knows here which is the code that it can use to validate the challenge. So to verify against the authorization server that it was indeed the one creating also this call here. So that's basically which makes it a lot more secure, because now you don't use the client credentials anymore, and every time when you have to authenticate and give the client the privilege to use your resources, the client can make sure that they are the only ones obtaining an access token for that specific authentication you did. And that's why using authorization code with PKCE is better than using the simple authorization code that just uses some client credentials every time. Client credentials that, being the same for every call, are much more sensitive. They can be stolen and then they can be used to obtain the access instead of having only your client being able to get the access token. Now someone getting the client credentials, somehow they will be able to do that as well, so it's less secure. So that's what you actually solve with PKCE. Is the same authorization code flow, just that here you create a challenge code, send it with the this is a little bit strange. I know in my diagram here I've represented the arrow from the user directly to make it more visible that the user directly communicates with the authorization server, but remember, this is still done through the client, so that code is not created by you, it's created by the client, of course. You are still working through the client. You are redirected here to a specific URL that you will see immediately. So I don't want you to understand that you are the one creating the challenge. It's still the client, as you will see, the one creating the challenge and the verification code. And assuming we are used the strong SHA-256 hashing solution, then the client generates both the challenge and the verifier, and you can use this as well. Okay, that's basically on the diagram how it's working. So maybe we will go back to the diagram after we have tested our implementation, but now we can actually try to test it. So let's just assume you are here, you want to access your accounts, the client doesn't have an access code, so we are at this arrow here where the client redirects you to a new URI that tells the authorization server to where you can tell the authorization server to allow the client access your resources and provide it back with an authorization code. So in this case, what we need to call it's the authorize endpoint that you find here. The authorize endpoint is this one. That's the one to which the client redirects the user so that they can authenticate at the authorization server, and that's the one to which the client also attaches a challenge, a code challenge, when redirecting the user to it. So this URI, this path, will also have a challenge already attached when you are redirected to it. So that's why the first thing we need to do as a client now, because we are using the authorization code with PKCE, is creating ourselves both a challenge code and a code verify for the challenge. And we can do that very easy, but I will avoid writing another app. I will just use a JShell here console to make it easier for us to create the codes that we need. So that is, we need somehow a random value, which is the code verifier. So secure random, it's something we can use to generate the code. Secure random, new secure random, and then we just want a series of bytes, which is the code verifier. I think 32 bytes should be enough. You say secure random next bytes, and you generate into this array, I called code, some random value, and then you transform the bytes using base 64 into a string that you can attach to your URI. So it should be something like code verifier base 64, and because I attach it to a new URI, I will encode, I will actually get an URL encoder. And then what I also do, I make sure that I make it without the padding, and then I encode to string the value of the code, which in this case becomes my code verifier. So this is what I will use as a code verifier in my flow. So this is something that the client does, and also the client needs to create the challenge. So we have the verifier, and the challenge is the SHA-256 hashed value of the verifier. Let me run this. How do I run this actually? Oh, it should be here. I'm not very often using the JShell, but I find it a good solution when I have things like this, where I would basically need to create another app for a demonstration, and it allows me only writing some lines directly without needing me creating one more project, useless project. So here is the code that I have. Here is the random code that I have created, and now I can actually open one more JShell console and try to hash this value. So how do I do that? I can use message digest md message digest get instance. We use SHA-256, and we need to use a try catch here. If we use a try catch, I don't know what this is, but it's not something I need. Message digest. Okay, and if we use a try catch, I believe that we actually need to print ourselves in the JShell the value, but that's another story. I will do that later. So what do I do here? I need to encode the verifier. So that's message digest, and my verifier value, I should find it here, is this one. I copy it. Is the one I previously generated, yeah. And I'm going back here, and I say take this value as a string and take the bytes of this value and digest it. This will return my hashed digested array of bytes, and then I transform it back into a base 64, and this is my string code challenge, and that's again base 64 get URL encoder encode to string without padding again. So without padding, encode to string this digested. And then because I'm in a try catch, I will basically need to write system out print line and print here the code challenge. And if I run this, what I should see is the code challenge I can use. This should be it. This should be the code challenge. You can see outputted here after the execution of my code. So now I have the challenge and I have the way to verify the challenge. And now we should be able to very easily prove the flow. So I'm going to my browser. The first thing the client does is redirecting the user to the authorization server. When it does that, in our case, did I start my application? I think yes, I've started my application. Yeah, my app is started, and I have both values, the challenge and the verifier. So I just need to say HTTP localhost 8080 and /auth2 and yeah, I've already tested it before, of course. You can see here, I will just avoid writing it again. You will see here, this is precisely how the call, the redirect from the client to the authorization server should look like. So first of all, we have the response type, which is code. This is something you already had when using the authorization code without PKCE. Again, you can go back into my Spring Security playlist or read Spring Security in action, and you will find the definitions of all this. I now assume that you know what these are. So the response type, which tells, in this case, the authorization server that we want to use the authorization code flow, not the implicit grant type. The client ID, of course, which is client1 in my case, if I remember correctly. We need to be very careful and use the correct details. Client1 in my case, so not client. So I'm here going to add one more one, client1. And then we have the scope. If I remember correctly, the scope I've added to this client is read. I'm going back to it. So the scope is read, which is fine. And then we have the code challenge. So the code challenge is the one created in the second JShell console, which is the hashed verification code. I copy this value as is, and this should be the value of the code challenge parameter. I put it here, paste, and then you have the code challenge method, which tells you, which actually specifies if we are using a hash or we are using a plain value. So that S256 tells the authorization server that we are not using the same challenge as the verification code, the verifier. We will have the challenge as an SHA-256 hash of the verifier. So that's really important to tell the authorization server what it should expect, because in the end it's the authorization server who will need to use the verifier, the code verifier, and prove that the verifier was indeed generated from the challenge. So this parameter here is important, because is the way you tell the authorization server to verify in the end that indeed the code that you will provide for the verification should be checked against the challenge that you send now. So you send the challenge and then you will send the verification. And you have the option to use a plain text, of course. That's the same challenge and the verification, but I've told you earlier why is this less secure. And now we will directly use the version that you will most often see in real world scenarios where you have the hash. So I'm going here, automatically redirects me to a login page. Here is where I have to prove who I am, me the user meaning Mary with the password. So I'm Mary with the password. And if I correctly introduced my credentials, when I press the sign in, I will be redirected to the redirect URI. In my case, this one here. Of course, we don't have it implemented, so that means we will get a 404, but I don't care because anyway we will continue our demonstration in Postman to get the access token. And that's the only thing I will need to see is the code, the authorization code that I get back. So that's why I don't care about implementing this endpoint. So I press the sign in, and again I get, of course, a 404, what I was expecting, but again what I need is actually this code. So that's why I have signed in for. So I copy the authorization code that the authorization server provided me. For this, up to now, we are still, you still see the same authorization code flow. So the only thing that differs with PKCE is the way the client authenticates. You still get the code back. You still need to use the code to get an access token. So now I'm going to my Postman and I will use the HTTP localhost 8080 auth 2 token endpoint, but instead of having to use the basic authentication as you were doing with a client and the secret when not using PKCE, now we don't use an authentication at all. And that's because we will have the client ID here, client 1, and instead of needing to use the client secret, and remember we don't even have a client secret here now, and the reason we don't have a client secret is because we are not using a client secret credentials way of authenticating anymore. We are now using the code verifier value here, and of course we need the code as well, and this is basically the authorization code. I think it's actually authorization code, the parameter. So I usually tend to forget sometimes the names because there are so many of the parameters, but I think it's authorization code. Of course we need to say the grant type, so we use the grant type, and the grant type is authorization code, the grant type. I'm not sure here if it's code or authorization code actually. And the verifier, the code verifier is the one in the first that we have hashed. So this one here is the verifier. And what will the authorization server do? The authorization server will take this one, will hash it again with SHA-256, and then it will see if the challenge that we firstly provided matches with the hashed value of the verifier. And that actually means that this verifier here indeed was the one that we used as a hashed challenge in the beginning. So that's basically how this works. So I think it's code here still, so it's only code. So yeah, I have provided the client ID. I said that the grant type is authorization code, and I have provided the code and the verifier, and I need the scope as well, of course. And if everything is fine, when pressing the send button and it's fine, we got the access token. So we got the access token without needing to use any client secret credentials. But even though we didn't use the client secret credentials, the way we've implemented the authorization code is actually more secure with PKCE, because now we are using some credentials that are per request, and per request meaning per authentication request by the user. And by this, we assure that someone may be managing to steal some static credentials as we were using without the PKCE, wouldn't be able now to find the same approach to get an access token. And that's because, again, going back to my diagram here, when the client redirected us, it created a challenge, which is the hashed value of a verifier. And then that has been sent through the authorized code, and the user managed to log in. So they have only authenticated for the client that knows the value of the verifier for that specific hash value. Being hashed, someone stealing the value cannot get the verifier, because you cannot get a value out of a hash. The other way around is possible. You can hash a value and get an output from an input, but you cannot get the input back from the output. That's what a hash is in crypto. So now someone has no option, because even if at this point they manage to steal the challenge, they still don't have the verification code. So now when we authenticated, we have actually only allowed that specific client that generated the challenge, and we are sure only that client now can issue a token. So it's not possible anymore that someone steals some credentials and they suddenly can intercept the authorization code and then get the access token, which could be used then to obtain access to the resources. And that's how the PKCE authorization code flow is more secure than the normal authorization code flow. And that's how, and we proved in this video, the version 002 of the authorization server works with PKCE out of the box. That was something not straightforward in the authorization server created with Spring Security OAuth project. And that's great, because it actually means that we are going to have an excellent resource in the end when this will become mature. And I promise you from now that when this will become mature, I will just write a second edition of Spring Security in Action where you will get all these details. But when will this become more mature, then we will have an excellent resource, and we will completely be able to replace the Spring Security OAuth project. Because remember what I've always told you, at the moment I still teach Spring Security OAuth, even though it has been marked as deprecated, just because you still find it out there in a lot of projects, and just because now we don't have a complete solution to replace it. We can replace the resource server, most of the things, but we can't replace an authorization server yet. But with this implementation, we will be able actually to replace the authorization server, and at that time we'll most probably can call the Spring Security OAuth deprecated. For the moment, it's not deprecated, even though it has been marked as deprecated, because that someone willing to use and willing to implement their authorization server, they cannot do that otherwise than using that so-called deprecated implementation. This is what will save us. I hope you enjoyed the video, and I hope you understood clearly what, first of all, what the version 002 of the experimental authorization server brings us. And secondly, I hope you understood how PKCE works. And again, that's something that many of you requested me to make a tutorial of. So now I've managed to create one, and I wanted to again wait until I could do that with Spring Security and not by using Okta or Auth0 or Keycloak or some other third party. So that's why I waited. Of course, the same approach, the same logic works with any authorization server. So if you try it with Okta, for example, PKCE authorization code with PKCE is the same thing, just that you use it with a third-party implementation. But it's anyway defined by an RFC, so anyone implementing that implements it the same way. That's why we have a specification. So now you actually know how to use authorization code with PKCE with any kind of authorization server. And I've managed as well to present you version 002 of the authorization server. Thank you very much for watching this video. I hope you enjoyed it and have a great time for study further.